This is a problem number 6 in chapter 11, which is a beam that has a concentrated load of 15 kips on it, but also a uniform load of 3 kips per foot on it. This beam's a little bit different because it has an overhang or a cantilever section over on the right hand side. There's a pin at A and a roller at B, so we have to go through the equilibrium equations as we've done previously and find the reactions at A and B. Those reactions would be 10 kips at A, 35 kips at B. After that, we can construct the shear diagram by simply summing the forces across the beam. The shear diagram will look like this. Again, 10 kips for the left-hand reaction up. Nothing occurs until you get to the 15 kip reaction down, which brings you down to -5. Nothing happens then until you hit the uniform load of 3 kips per foot. Now notice for the first 5 feet that pushes you down to -20, but then the 35 kip reaction pushes you back up to 15 kips. And then the remaining 5 feet of uniform load pushes you back down to 0. After that, we can sum the areas under the shear diagram. The rectangle on the left will have an area of 50 foot kips. The rectangle down below 0 will have an area of -25 foot kips. The trapezoid there will have an area of -62.5 foot kips, and the triangular area at the end of the beam has an area of +37.5. So once we have the areas, we can construct the moment diagram, and again you can see the maximum moment occurs where the 15 kip load is, and that maximum moment is 50 foot kips. The only other thing that I'd note is the trapezoid and the triangle. Of course, the moment diagram, they're not straight lines there because the area under the shear diagram is changing, so they are parabolic curves.